This is the equation of a quadratic in standard form. Y equals ax squared plus bx plus c. There are a few things that we can tell about it from looking at the equation. It's quadratic, which means what shape does it make? A parabola, right. If you look at that sheet that you had, where you were exploring quadratic functions in standard form, you would probably see that this, if a is greater than 0, the parabola opens up, just like it was in vertex form, which means this isn't any better than vertex form, right? Still tells you that. If a is less than 0, the parabola opens down. A also determines how wide or narrow the graph is, but we're not going to get into that very much. Just know that the a value affects how wide or narrow it is. One thing that you may have noticed is that c represents the y-intercept. So whatever constant you have at the end is the y-intercept, which makes sense if you think about a y-intercept. A y-intercept is the y value when x is equal to 0. So if you put 0 for those x's, all you're left with is y equals c. So that's the y-intercept. This form doesn't seem that useful. I don't work in standard form very often. If I want to write the equation of a parabola or solve a quadratic equation, which we'll get to later, all those things, we don't work in standard form. But the thing about standard form is that it's standard. What? It's the same for all different types of functions, quadratics, cubics, quartics. All polynomial functions have a very similar standard form. And that's why it's a good form. It's not good to specifically tell you things about parabolas, but you can see the similarities between quadratics and cubics and quartics when you look at standard form. Unfortunately, we're not going to do that in this class, but we still have to be aware of standard form and be able to work with it. Really, the thing that we're going to do most with standard form is figure out how to take an equation in that form and switch it into vertex form. Because once it's in vertex form, then we know lots about the parabola. So that's the main thing that we're going to learn to do. But I have one more thing here to show you, which is in your textbook, so I included it here, but it's actually not something that I ever use. You can find the vertex from standard form, and this is how you do it. The p-value of the vertex is negative b divided by 2a, and the q value is c minus ap squared. I'm going to show you how to do it. You don't have to use that because I'm also going to show you how to take an equation in standard form, switch it into vertex form, and then you'll know the vertex. But some people like to do this, so it's up to you. But we're going to do one example of it anyway. So we're going to find the vertex of y equals x squared minus 8x plus 7. There's not going to be any question like on your unit test or your exam that requires you to use this method. You'll have other methods if you prefer, but if you like this method, then we'll use this method. What we need to do here, though, is think about what is the a value in this function. And a, remember the standard form was y equals ax squared plus bx plus c. What's the a value? 1. And what's b?
8.
Negative 8. And c? 7. So then when I want to find the vertex, the p value is going to be negative b, so negative 8 over 2 times a. So that's actually positive 8 over 2 or 4. Right, just simplifying that. The two negatives make a positive. 2 times 1 is 2. 8 divided by 2 is 4. So the vertex of this has an x value at 4. And then to find q, it's c, which is 7, minus a, which is 1, times p squared. So 4 squared. And that works out to negative 9. 7 minus 16, negative 9. Which means for this quadratic, y equals x squared minus 8x plus 7. For that quadratic function, the vertex is at 4 and negative 9. So that's one way to find the vertex. If you want to use this method, you have to memorize these two little formulas here, the P formula and the Q formula.